High-altitude weather balloons, they are not new. They've been around for ages. Geologists and scientists have used them to gather important scientific data from the upper reaches of the atmosphere. And if you remember, a few high-altitude balloons were in the news a couple of years back when these Chinese balloons were going across the American airspace and they were shot down by the US. But that's another story for another time. This story has to do with this ingenious company that is mating rockets to these high-altitude balloons, using the balloons to hoist the rockets to the very edge of the stratosphere and then firing the rockets. The result is that the rockets need much less fuel and it's much more efficient to get to space. Why didn't somebody think of that before?
Getting a satellite into space usually means using a rocket, and that can be very expensive. Now, a UK-Spanish startup is trying a different approach using a giant balloon. B2 Space uses stratospheric balloons to carry satellites and rockets high into the sky to the edge of space. The idea is simple. Take the rocket up first, then fire it from high altitude to reach orbit. B2 Space calls one part of its approach near space testing. Instead of sending a satellite all the way into orbit just to see if it works, the balloon takes it to high altitude, where it can experience conditions similar to those it will face in space. That includes very low air pressure, high levels of ultraviolet radiation, and extreme temperatures. The aim is to find problems before the satellite actually reaches orbit.
Today, a lot of satellites fail on the first days of their missions in space, so we are helping our customers reduce that risk.
But the balloon is not just a testing platform. B2 Space also offers launches with what it calls a Rockoon, a combination of a rocket and a balloon. The balloon lifts the rocket to around 35 kilometers above Earth, above more than 99.9% of the atmosphere. Only then does the rocket fire. The company plans to use a 3-stage solid fuel rocket to carry small satellites into low Earth orbit at altitudes between roughly 200 and 1,000 kilometers. The advantage? The rocket does not have to fight its way through the densest part of the atmosphere from ground level. And that could mean less rocket and potentially lower launch costs. The same high-altitude technology can also be used to test what happens when hardware comes back down. B2 Space says its balloons can carry payloads ranging from a few kilograms to several tons, including drop tests of up to 10 tons from the stratosphere. That could allow companies to test re-entry systems without putting them through a full orbital mission. And the scale of these balloons is significant. The company says its larger systems could even carry something as heavy as a car. Then, there is another use for the same high-altitude technology. B2 Space is developing high-altitude pseudo-satellites. These platforms operate above around 18 kilometers, sitting between satellites in space and drones closer to the ground. A satellite can pass over a location and capture a snapshot, but a high-altitude pseudo-satellite platform can stay over the same area for much longer. That opens the door to continuous high-definition monitoring, including real-time video.
For example, if we are monitoring a wildfire, we can provide live actionable information to their emergency responders so they can see in real time how the situation is evolving. So we are a perfect complement to drones that also can provide information but of a small area because they are flying very low. So we are basically complementing both of them.
And that could make high-altitude pseudo-satellites useful in places where both satellites and drones have limitations. For example, maritime surveillance across large areas, emergency communications when ground networks go down, or backup connectivity during a crisis. The big idea here is not to replace rockets, satellites, or drones, but to connect their capabilities. A balloon can take hardware high into the atmosphere. A rocket can then take a small payload the rest of the way to the orbit. And a high-altitude pseudo-satellite platform can stay in the stratosphere, watching, communicating, and collecting data. For a space industry looking for cheaper launches, more testing, and longer-lasting connectivity, the route to space may not always start with a rocket on the ground. Sometimes it could start with a balloon.